Father, we thank you for today, for your grace and mercy. Thank you for your love. Blessed be your holy name. As we start now, we ask and pray your presence start with us. Grant us wisdom, understanding. In Jesus' name.
Amen.
Amen. Okay. Okay. Before that, we're trying to look at evidence in support of rectilinear propagation of light. What's the first one we said? What are the evidences that proves that light travels in
Formation of shadows.
formation of shadows? Number two,
Formation of eclipse.
formation of eclipse. And the other one is the pinhole camera, which I showed you a video of it. Okay, the pinhole camera we said is a device. It has a rectangular pin with a pin in one of its faces and a film screen on the face opposite the pinhole. I told you that light rays from an object will pass through the pinhole and form the image on the object. The image formed has the following property. I said the image is real. The image is inverted. I said the image is diminished. Okay. And I also said that the image itself is diminished if the distance of the object from the pinhole is greater than the length of the camera. Otherwise, the image will be magnified. Also, I also said something on that the smaller the size of the pinhole, the sharper the image. And if the size of the pinhole is too big, the image will be blurry. And I said to increase the magnification of the image of the pinhole, you move the object close to the pinhole. The last thing I was meant to give you on that is that I'm going to give you the formula for magnification of image. So that's under the pinhole camera. For the pinhole camera, the magnification of the image formed. The magnification of the image formed. Okay, please write this. Magnification of the image formed is giving us magnification of the image formed magnification of the image formed okay, magnification of the image formed is giving us M is equals to HI over H naught. That's, where is it? M is equals to HI over H naught. Okay, HI over H naught. Now, which is also equal to, now when we talk about HI, now if you're talking about HI, okay, that's not the end. We also have a magnification is also equal to V over U. Magnification is also equal to V over U. So equating both of them together, therefore we'll be having, equating both of them together, we'll be having coming hi over h naught is equals to v over u. Is equals to v over u. And that is, things are coming up now. Okay. What is hi? Right, hi is equals to the height or size of the image. Please write hi is equals to the height or size of the image. H naught is the height or size of the object. H naught is the height or size of the object. The V is the image distance. V is the image distance. V is the image distance, and U is the object distance. U is the object distance. So I take that again. That hi over h naught. Okay. Now hi is equals to the hi has to do with the height of the object. And h naught is the size or the height of the object. Okay. Now the other one, the v is the image distance. The v is the image distance, and the u is the object distance. So with this now, let's see an example to solve. Let's see an example to solve with this. Okay. Okay, please take this down. The length of a pinhole camera is given as this.
I'm done.
Okay. Okay, magnification is equals to hi over this. Okay, and that gives us 80. Awesome, awesome. That's Awesome. That's awesome. All right. All right. Let's go to another one. The length of a pinhole is 12 cm. Okay. That's the um, image distance. Is used to photograph an object. 60 object distance. Okay, and 80 cm height. Okay, awesome. Now let's do this. The next one. Okay. Um, okay, you can do this also.
Secretary, I need to change my position.
Sorry?
I need to change my position. You want to do something?
Okay. Um, okay, can you show me what you've done here?
Yeah.
Okay. Wow. Let me see. It's all right. So what's the magnification?
0.2.
0.2. It's okay. It's okay. Awesome. Um, let's see. Okay, another. We have just two more to just two more. Um, okay, let's see this then.
Hmm? Oh, that's me. That's me. Oh. What's going on?
Now, let's see that again. The distance between the pinhole and the screen of a pinhole camera is 12.5. That's the image distance. And the plate is 2 cm long. That's the what minimum distance from the pinhole must a 1.8 man must a 1.8 meter tall man stand if a full length of photo is required. So what are we looking for there now?
The object distance.
Sorry?
Object distance.
Okay, okay, awesome, awesome. And the last one, okay, with that coming, all right. The last one will be given then will be okay, this okay, this one. All right, please do this also.
Okay.
Wow, awesome. Sorry, have you done this before?
No.
Wow, that's a good one. I'm really, really impressed with this. Um, this is amazing. This is really amazing. Okay, what's the height of the image? Okay, okay, okay. Now, I think, okay. So today we will be advancing with what we were doing before now. Just have to advance with um, uh, let's advance with this reflection of light. I think we've done reflection of light, right?
Yes.
Okay. I think we'll just go more into something on reflection of light. Okay. We understand that light waves undergo reflection, and the nature of reflection depends on the type of surface the light is actually incident on. Now, we have two types of reflection. Number one, we have the regular reflection, and we have diffused reflection. Please, two types of reflection. Number one, we have regular reflection, and number two, diffused reflection. Okay, now if the reflections are such that the rays are parallel to one another, if the rays are parallel to one another, we call that that parallel to one another and they are in one direction. They are regular. That we call them regular reflection. And most times this happens when light is on incident on a smooth surface or polished surface. But if the rays of light are, if the rays of light, we see the rays of light coming up on, if they are reflected in different directions, if the rays of light are in different directions, we call that kind of reflection diffuse reflection. Okay, what do I mean by that? This is exactly what I mean.
So
Um,
please correct what you said about diffuse reflection.
okay, what I said about diffuse reflection, I said if the rays of light are incident on a rough surface, if the rays of light are incident on a rough surface, the rays will be reflected in different direction. The rays will be reflected in different direction. That's what we call diffuse reflection. Okay, did you get that, please?
Yes.
Okay, okay, so let's come. I wanted to explain that, what I mean by that. Now, if the rays of light are incident sorry, this is not so smooth. Okay, this is what we call regular reflection. But when we have the rays of light, then one is going on another direction, down different um, ways. They call them diffuse. So what we said about diffuse, regular reflections are actually done on smooth or polished surface, while diffuse reflections are done on rough surfaces. Okay, all right. Have I given you the laws of reflection?
No.
Laws of reflection. Okay, please write this. Laws of reflection. Laws of reflection. Please write the incident ray, the reflected ray, and the normal ray at the point of incidence. The incident ray, the reflected ray, and the normal ray at the point of incidence all lie on the same plane. Okay, have you written that? Have you written that? Yes, I said the second one is the angle of incidence is equal to the angle of reflection. So this means that from here, I, and here, R. So the angle of incidence, that's I, is equal to R, is equal to the angle of reflection. Okay, let's look at formation of images by plane mirrors and curved mirrors. Formation of images by plane mirrors and curved mirrors. Formation of images by plane mirrors and curved mirrors. Okay, number one.
What's that?
Now,
Come on.
let's look at number one.
It's working, man.
Formed by a plane mirror.
Come on.
Number one, image formed by plane mirror. You're going to be looking at the kind of images that are formed by plane mirror, where we have the mirror, we have the objects, you come in, please. Now, this is what I was trying to explain to you, that the images formed in a plane mirror. This is the image formed in a plane. This is the kind of image that's formed in a plane mirror. Now we see the image, the object is here. Okay, this is the object. Let me use something else too. Okay, so this is our object. This is a plane mirror. This is you looking at the object. This is you looking at the mirror with this object. Now, what happens is this: the object is formed behind the mirror. The image, sorry, is formed behind the mirror. And because it's formed behind it, this is what you get to see. So these are the kind of images that are formed in the mirror. Now we have I'm going to make a labeling of some of these things. I'm going to make a labeling of that. That's this is, oh, come on. A, B, C, D. This is N. That's normal ray. This is your O object. And then the image. This is I for image. Okay. So with this now the incident ray OA, the incident ray OA and OB. Now where's the incident ray? OA and OB. Remember the incident ray, the ray that goes into the mirror, the ray that goes into the mirror. So it will have this goes into the mirror, and then this is the image, the reflected ray, okay, that you are seeing. All right, now the incident ray OA and OB from the tip O, when they strike the mirror at A, strikes the mirror at A and B, what happens? They become reflected as C and D respectively. Now, when this A and C, when the A and C, when the AC and BD are extended backward, they intersect at that point at the image I that we have there. And this is why you see that point. This is why you see the point as if it was even located behind the mirror. You see it as if it was located behind the mirror. But what we should know is that the ray ON that we have there is also reflected back long. So the virtual image is the one that is formed by the intersection of the light rays. And that is what we can see there. So I'm coming, please. This coming. Okay, okay. Now, like we said, this is the object. The object is held to the mirror. Now it reflects, the incident ray comes upon the mirror and then reflects back to the eyes. Now, for you to get the image that was formed, you see the way I carefully did this? I drew the incident ray to the mirror and then the reflected ray to the eyes. Now, where both of them, they will intersect at the points. Where they intersect is the image formed. And what is the characteristics of the image formed there? We see that it is, we have two types of image. Number one, we have virtual image and we have real image. Please, I need you to write that down. We have virtual image and real image. Virtual image and real image. Now, what is a virtual image? A virtual image is one that is formed. This is right. A virtual image is one that is formed by the apparent interception of light rays. A virtual image let's get that down here. This is it. A virtual image is one that is formed by the apparent intersection of light rays, while a real image is the one that is formed by the actual intersection of light rays. What do I mean? Actually, this was meant to be a dotted line, but I could not find um, dotted lines for this. Oh, this was actually the ones here. Oh, sorry. The lines here, the one at this side, these lines here, they were meant to be dotted lines. They were meant to be dotted lines, but since I didn't see one, that's why we have them like this. So if you are doing yours, I want you to make the yellow line from here, that's N to I want you to make it dotted lines. From B to I want you to make it a dotted line. From A to I want you also to make that dotted lines. Do you understand that, please?
Yes.
Okay. So please make them dotted lines. Now, let's come back to this. A virtual image is one that is formed by the apparent intersection of light rays, while a real image is one that is formed by the actual intersection of light rays. Actually, what do you think would be the kind of image that is formed in this plane mirror? Is it virtual, or is it intersection, or is it actual image, or is it real image? Sorry.
Virtual.
Virtual image. Now it is virtual because the rays do not intersect to form the image. The rays do not intersect to form the image. And one major difference between virtual and real image is that the real image can be caught on a screen, but virtual image cannot be caught on a screen. Okay, so please get that down. One major difference between a virtual image and a real image is that the virtual image can be caught on a screen, but a real image can be caught on a screen, while virtual image cannot be caught on a screen. So the image formed in a plane mirror is actually a virtual image. Have you written that down, please? Hello, have you written that down?
Yes. Yes.
Okay. All right. Let's look at the characteristics of plane mirror, of images formed by plane mirror. Characteristics of images formed by plane mirror. Characteristics of images formed by plane mirror. Number one, can you give me one of the characteristics? Hello?
They form they form virtual images and real images.
Okay, please write. The image is virtual. The image is virtual. Number two, it is far behind the mirror as the object is in front of it. It is far behind the mirror as the object is in front of it. Number three, it is the same size as the object. It is the same size as the object. Number four, It is upright and laterally inverted. It is upright and laterally inverted. Okay. Now, let's look at images formed by inclined mirrors. Images formed by inclined mirrors. Please write this down. When an object is placed in front of two mirrors, when an object is placed in front of two mirrors, when an object is placed in front of two mirrors, they are inclined to each other. A number of images can be observed, or a number of images can be viewed by an observer. A number of images can be viewed by an observer. A number of images can be viewed by an observer. Remember, we are looking at images formed by inclined mirrors. Okay, now I wouldn't know if you've tried it before, but when you put, have you tried putting two mirrors? You are the middle, one is at the center, or sorry, you are the center, yes. One mirror is at your front, another mirror at your back. Have you tried that before?
No.
Okay, if possible, you could try that now. You could try that. You are going to see lots of images at your back, or not. Yes, you are going to see lots of images. You're going to see your back coming again to your back, coming again to your back, coming again to your back. Okay. Um, okay. Um, Let me get a video on that, if possible. Okay.
Good grammar and spelling are important, but if you want
Um,
good grammar and spelling,
I would
are
want you
important,
to see
but if
the video of what I'm talking about. So, but please write this equation down. That's the equation for the number of images is given by the equation n is equals to 360 over theta minus 1. Please write theta is the angle of inclination of the two mirrors. Theta is the angle of inclination of the two mirrors. Now, I want you to try, if the angle is placed, if theta is 60 degrees, can you tell me the number of images you're going to see?
Second 47.
So I want you to try that if theta is 60 degrees, Can you tell me the number of images you're going to see? If theta is 60 degrees,
Five images.
5 images. Okay. I want you to try again. What if they are placed at 180 degrees?
So what did you say?
180 degrees.
Second person said.
I say, what if they are placed at 180 degrees?
One image.
That means if theta is 180 degree,
Yeah, placed at,
sorry, what are the number of images
you
you will see?
see one image.
Sorry?
One.
One. Okay. That's why when you have only one, okay, that's good. That's why when you have only one mirror placed, maybe if that's in a barbing salon or in a hair salon, when you see one mirror placed there, the only image you will see there is one images. You're going to see just one images. Okay. I think I have the video now, so let me show you this before. Okay. Come on, where are you? Okay. Can you see this?
Yes.
Okay.
Hello, scientific audience. One of my most awaited experiments. The image formed by two plane mirrors at some angle. For this experiment, I require two plane mirrors, this candle. During this experiment, you may choose to lit the candle or not. Now, this is the most important part of our experiment. I asked my carpenter to make some grooves on a piece of wood. This is a simple plywood of 18 mm thickness, and I had drawn two lines, this one and this one, having angle 120 degrees, and I gave it to my carpenter, and this is 4 mm in thickness because the plane mirrors are approximately 4 mm thick. So he had made the carvings of 4 mm thickness. Now this one and this one, these two lines are at 120 angle, these two lines are at 90 degree, these two lines are at 60 degree, these two at 45, and the these two lines at 30 degree. Correct. So I'm going to arrange the mirrors at 90 degrees like this. Also, I'm going to put an A4 size of paper over here. Now I must ensure that both the mirrors are joined together properly. Okay, done. Right? Now, what are we actually doing in this experiment is, this is our object, and I'm choosing to keep the object over here. Right? Now, there are two positions in which you can keep the object. One is on the angle bisector of the mirror, that is called the symmetric arrangement of the object from both the mirrors. So you can do that. So here, if I keep an object on the angle bisector, that means From this mirror, this angle is 45 degree, and from this angle also, the angle is 45 degrees. So exactly on the angle bisector line, symmetrically, I am putting the object. Now, let me say one thing, that what is going to happen over here is, now since there are two mirrors, I'm going to call this as mirror M1, this as mirror M2, right? This is the first image of this candle in mirror M1, and this is the second image, and this is also the first image of this candle in mirror M2. Now, these two are called the primary images. Now, this primary image will behave as the object for the image of this mirror, guys. See, this image is visible over there. The image of this mirror is visible over there. And we can also consider that we can extend this mirror behind. So this is our extended mirror behind. We can extend the mirror behind. So this image will behave as an object for that extended mirror, and its image will be formed on the other side. Let me show you that. So that is very well visible, that now this image will behave as the object for that mirror, which is the extended. We can consider this mirror to be extended behind, or that is the image of this mirror in this mirror, or simply you can consider this as the extended mirror, and that is the secondary image of this primary image, because this is behaving as the object for that mirror, right? Now, this secondary image cannot behave as the object, because you can see that this is the reflecting part of the mirror, and this image is formed behind the mirror, so you have to stop there, correct? And the total number of images that you are seeing in this case is 3. Now, guys, sometimes what happens is, there are 4 images, but the last 2 images are falling on one another, like in this particular case. The image of this is here, and the image of this is coinciding on that one. So we are considering that image as the one image. Actually, there are 2 images, but they both are coinciding on one another. So hopefully, guys, I have told you what is the theory part. And now let's start the experiment by keeping the angle between the mirrors as 120 degrees. So guys, now the setup is ready, and the angle between both the mirrors is 120 degrees. This angle is 120 degrees, and this is the candle which is exactly at 60 degrees from both the mirrors. So it is on the symmetrical distance from both the mirrors. From here also 60 degree, from here also 60 degree. Now the formula says something like this. You can just see on the screen. So here from a distance we are able to see 2 images. Let me show you by bringing the camera more nearer. So guys, there are 2 images which are formed, and if I move around a bit, there is no third image which is seen. But if I displace this candle somewhere over here, and if I keep it at some asymmetric distance from both the mirrors, the number of images tend to change, guys. So this is the first image, that is the second image, and if you there you see, there is a third image, guys. So total there are 3 images which are obtained when you keep this candle or the object at different distances That means asymmetrical angles or distances, you will find 3 images.
Hello, are you understanding what is happening there?
Yes.
Okay. Okay, we're going to stop there, but I think there is another one which I just wanted us to look at. Okay. Come on, not this. Okay. Okay. Um, all right, bye for now. Where is it? Okay.